protocol, that is graph based protocol, that we are going to see. So graph, as its name is given here, it is a graph related, or we are going to draw a graph for it. So graph based protocol are alternative to two-phase locking protocol. As its name graph means we are going to draw a graph, but it is a acyclic graph. So acyclic graph means tree. Okay, acyclic graph means tree, and that's why it is also known as tree protocol. It is also known as tree protocol. So what is this graph protocol? That first we are going to see the definition. It imposes a partial ordering. How we show the ordering? With the simple arrow. It shows a partial ordering on the set of data items d1, d2 to dn. Where if di, suppose I draw here in this way, di, dj. What it indicates that? The transaction access, if any transaction ti accessing both the data items di and dj, then it first access di and then access dj. That is the simple way to represent this arrow. If there is a di to dj, there is a direction from di to dj, then what it indicates that any transaction ti accessing both di and dj, then it first access di and then it go for dj. So this kind of partially ordering implies that the set of data items d1 to dn which are shown as a directed acyclic graph. Directed acyclic graph, which is known as database graph and also known as a tree protocol. Acyclic graph means it is tree. Now see the rules for this. So that is shown here. Example of tree protocol, you can see here A start with the data item A, means any transaction which access these two data items, first it access A and then go for B. First A then go for C. If want to access F, first A then B then F. Okay, so that is about it. Now see the rules for it. In the tree protocol, okay, in the tree protocol, the only lock instruction allowed is lock X. Means here the shared lock is not allowed in tree protocol or in the graph based protocol. Only lock instruction allowed is lock X. Each transaction Ti can lock a data item at most once. Means if a transaction Ti lock a data item B, then and unlock it, the transaction not allowed to lock it again. So each transaction Ti can lock a data item at most one, maximum one time it can lock. Then the rules for this. What are the rules? The first rule that already told that only exclusive locks are allowed. Okay. Shared lock is not used in tree protocol. The first lock by Ti may be on any data item. The first lock by Ti may be on any data item. Means the Ti can start with data item B directly. Means lock request X only on data item B. The first lock by Ti may be on any data item. May start directly with H, may start directly with I, may start directly with F, D, G. Not necessary start with A. Okay, next rule. Subsequently, a data item Q can be locked by Ti only if parent of Q is currently locked by Ti. Subsequently, a data item Q can be locked by Ti if parent of Q is currently locked by Ti. Now see what is the meaning of this statement. For example, suppose the transaction Ti first start with data item lock X on B, and then the transaction start with data item B, lock acquired on data item B, and then want to lock H, then want to lock H or want to lock J. So in that case, not possible to directly lock J. The parent should be locked first. So what is the parent of it? Lock D. First need to lock D and then need to lock H and then lock J. Have you got? Subsequently, a data item can be locked by Ti only if parent is locked. See, if Ti first start with the transaction or data item B, get a exclusive lock on B, and then want the data item J. Not possible to directly lock J. Before that, need to lock its parent D and H. And that is disadvantage of tree protocol. One of the disadvantage. See another example. Suppose it start with data item B. Another transaction Tj start with data item B. And after that it want to lock the data item I. Not possible to directly lock I. Before that its parent should be locked. So lock E and then I. So I think it is clear to you. Now the next one. Data items may be unlocked at any time. B is locked, then E is unlocking of that is allowed. A data item that has been locked and unlocked by Ti cannot be subsequently relocked by Ti. Means that already I told that a Ti can lock a data item at most once. Okay, at single time only lock and unlock the data item. So remember these rules. First is the only exclusive lock is allowed. The first lock on Ti may be on any data item, but subsequently a data item Q is locked by Ti if the parent is already locked by Ti. And data items may be unlocked at any time. At any time, the data items may be unlocked. A data item that has been locked and unlocked by Ti cannot be subsequently relocked. Okay, again relocking is not allowed. So these are the rules of this tree protocol. Some examples are given here. You can write any example. So first example is shown here. T10, suppose it lock the data item B, then it lock the data item E, then it lock the data item D, then unlock B, release this lock, unlock E. Now D is already locked, correct? And then it lock G. G is allowed. Why? Because the parent is still locked by. Then unlock this one. Second T11, it lock first D, then lock H, unlock D, unlock H. Then T12, lock B, lock E, unlock this one. Lock, then D, H, and unlock D and H. So in this way, these are the examples or some cases or case studies. Not necessarily in the same way you have to write in the exam. So what are these? Another example, suppose this, the same example, T8, T9, T11, T10, T11, T12 and T13. If these are executed concurrently, how it will be executed? Now this is again example. It is a schedule, okay, where these 4 transactions are executed concurrently. So we call it as a concurrent schedule. So it start with locking the data item B, lock, then go for the then go for the data item or the transaction T11, lock D, lock X, unlock D, then it lock. Here it is unlocked, that the T10 can lock the data item D, unlock B, unlock E, then it goes for transaction T12 concurrent execution. So switching the execution, some of the instructions of T10, then T11, T12, T13 in this way. Then here it is unlocked and that's why this lock is granted. It is unlocked here, that's why this lock is granted. Then move towards the again T11, unlock H, lock G, unlock D, then move towards the concurrently to T13. Here it is unlocked and that's why it is allowed. Here it is unlocked, that's why it is allowed. unlock D, unlock H, go here, unlock E, unlock B, unlock G. It is not a single case. Okay. In this way, multiple schedules or concurrent schedules are possible with these 4 transactions. This is one of the example of concurrent execution or concurrent schedule. So now see the advantage and disadvantage of this graph-based protocol. So the tree protocol ensures conflict serializability as well as freedom from the deadlock. So that is two disadvantages of graph-based protocol, that it ensures conflict serializability as well as freedom from the deadlock. Unlocking may occur earlier in the tree locking protocol. Here you can see that these are unlocked earlier. Data items are unlocked earlier. Here you can see it is unlocked here, it is unlocked here, unlocked here, and that's why once it is unlocked, it is allowed to lock by another transaction, and that's why it increases the concurrency. That is one of the advantage. So unlocking may occur earlier in the tree locking protocol that in the two-phase locking protocol not there. So shorter waiting time, another transaction not necessary to wait, increase the concurrency, protocol is deadlock free, no rollbacks are required. But here are some drawbacks. Protocol does not guarantee recoverability in cascading freedom. So here if a cascading rollback occurs, it may create the problem. And another drawback is that here the transaction may have to lock the data items that do not require or do not access. The transaction may have to lock the data item that they do not access. It increases the locking overhead and additional waiting time. So for examples, here suppose after B is locked and after that if B is locked and after that J is required by the particular transaction Ti, not possible, for that it need to lock this D and H also. Means it increase the locking overhead. The data items which are not required also accessed by that or need to access by that transaction. That is one of the disadvantage of tree protocol. So potential decrease in concurrency. The schedules that are not possible under two-phase locking protocol are possible under this tree protocol or vice versa. So that is